Question one. Question one talking about the isotopes. The bromine occurs naturally as a mixture of two isotopes, bromine 35 and then 79, and then bromine 3581. The relative atomic mass of bromine is 79.9. The first question is about list the number of protons, electrons, and neutrons in an atom of bromine 35 and then 79. We have to remember that the lower number that we have should be the atomic number, while the atomic number will be equals to the number of proton, while the upper number will be equals to the mass number. The mass number is the number of proton plus the number of neutron. So that's why with this kind of notations, 35 and 79, we can easily find that the number of protons in this isotope should be 35 protons inside, while for the number of electrons, there should be 35 electrons as well. So don't forget the charge of an atom, positive charge and the negative charge would be the same. So this is the first reminder, positive charge and then the negative charge here will be the same. While the number of neutrons, so the number of neutrons, we can find it in the mass number. Number of neutron plus the number of proton will be equals to the mass number. As a result of that, it should be 79 minus 35, it will be equals to 44 neutrons altogether. So from the notation, we can understand the number of proton and neutrons. And if you take a look, what is the meaning of isotope then it would be refers to the atoms of same element, and which have same number of proton, but different number of neutrons. They have different mass number, while their atomic number, that is the number of protons, will be the same. So their only difference would be the number of neutrons then. Next one, calculate the percentage abundance of bromine 79. So the percentage abundance of this one related bromine 79 related, let the percentage of abundance of bromine 79 be X%. If we got this, then 79 times X plus 81 times 100 minus X divided by 100, then it will be equals to 79.9. That is, we are talking about the relative atomic number. It's the weighted average of all isotopes. All isotopes included 79 and then 81. And then how to take average? 100% of bromine contain X% of 79, and then the remaining one must be 100 minus X% of 81. So once we put it here as a result, so X, when we calculate it, it should be 55. So the percentage abundance of bromine 79 will be equals to 55%. So don't forget, as you are letting X%, so X should be a value without percentage. So the percentage abundance, that is the concluding sentence, the percentage abundance of bromine 79 will be equals to 55. Question D. Bromine belongs to the same group as chlorine. State and explain whether bromine or chlorine will react with hydrogen more vigorously. So we have to think about which one react more vigorously. And just because for this one, you have to know that which one is the most reactive one. Then hope we remember that chlorine react with hydrogen more vigorous. So as it is asking you to state, you give the statement first. So we have to choose one of them. We say that chlorine reacts with hydrogen more vigorous. But what is the remaining reason? The remaining reason is we need to talk about the same group nature. So for group 7, they belongs to the same group. So for group 7, we need to know that bromine is below chlorine. Better use back the word instead of the symbol. So bromine is under chlorine. The reactivity of group 7 decreases down the group. Now, we need to use this sentence as well, because this is very obvious. Group 7 decreases its reactivity. And we need to tell, oh, bromine actually, it is in a lower position than the chlorine. That's why chlorine is more reactive, more vigorously reacting, right? So for 2, write a balanced equation for the reaction in 2. Now, bromine or chlorine. So it should be start with chlorine because we are having chlorine is the most vigorous one. So chlorine react with hydrogen, then it will become HCl. So it is given that the product is a gas. So this is a gas. While when we need to balance it, as the left-hand side will contain 2 hydrogen atoms and 2 chlorine atoms, as a result, we should have 2 HCl. While chlorine is a gaseous element, while hydrogen is also a gaseous element. For nonmetals, most of the nonmetals are the gaseous elements. So it should be gaseous here. If we want to state the physical states, we should write it like this way. Suggest the electronic arrangement of bromine. Now, for bromine, actually, it is purine. It should be purine, and then group 7. As a result, we state that it should be 4 electron shells. For 4 electron shells, the first 2 must be 2,8. And then the last one must be 7, just because it is group 7. As a result, must be 7 in the outermost shell. Altogether, there is 35 electrons minus 2 electrons in the first shell, 2 electrons in the second shell, 7 electrons in the outermost shell. There should be 18 electrons left. As a result, this is the 18 electrons here. So this is the question 1.